Okay, so the time now is 5:43 p.m. Today is Monday, March 23rd. I have an interview coming up tomorrow, so today I'll keep it light and breezy. Try to solve one question in 45 minutes before I proceed on to do something else. So I think today we will start off with another easy question. Let's see, the last easy. All right, just to finish off as a warm-up. Okay, so it's sim tree. Actually, I've done this question before when I was doing the subtree of another tree. So let's see if I can still implement it. So given the roots of two binary trees, return true if both trees are equivalent, otherwise return false. Two binary trees are considered equivalent if they share the same exact structure and the nodes have the same values. P123, Q123. Okay, so this one will be false. All right. Okay, so this one is actually tree. You can do it for depth first search or breadth first search. So if we are looking at level order traversals, right? So I think there's one question. Binary tree level, this one will require a queue, but subtree of another tree, the one that I did, yeah. So we actually have this. So this question is also an easy, but I recall I spent like 2 hours on it. So I'm not gonna look at it. I'm just gonna think about it, and then let's see how it goes. All right. So we will have to look at the number of nodes, right? So if P if node P, let's call it the first tree, does not exist, and node Q does not exist, I will return true. Because if both nodes don't exist, then no tree is equal to no tree, which sounds valid, right? So if P exists, if no Q, then or no P, so both of them are not true. So now is either one of them is not true, I'll return false. So let's just return true and see if, okay. Okay, so now okay, so this one still holds true. So if let's say there's P, so at this point you can say that either one of them exists because both of them don't exist, doesn't get included in this case. So if both don't exist, you return true. If only one of them exists, which is in this case the invariant is that either one must exist. So either Q exists or P exists, you return false. All right. So now we will have to check if the left subtree, we will check whether the values are the same, right? So if P dot val is equals to Q dot val, I will return uh I will return this dot same tree P dot left Q dot left, and it must be n. This dot is same tree P dot right Q dot right. Okay, this dot is same tree P dot right Q dot right. Okay, yeah. So if they're not equals, the same will just return false. So let's try. And we submit. And we stored. Yeah. Okay. So I think the solution would be something pretty similar where we use depth first search. Okay, wait. If I just do recursive DFS, it will look something like if no P and no Q, return true. If P and Q and P val, I mean, this is effectively the same, right? So if P and not Q, right, I'll return false. So either one of them exists, I'll return. Then if P val is equals to Q val, then I'll return the same tree left and same tree right. Okay. So let's take a look at subtree of another tree. So we will need to run this function. And if there is no subroot, empty tree is the subroot of any tree. Okay. Then if there's no root, the invariant is that it has a subroot, so it's false. So if it's the same tree, right, I'll return true, right? If they are exactly the same tree. But chances are this won't go. So I'll return if it's subtree or it's subtree right on the right side. Then it's pretty easy. Then I'll just keep recursive. All right, I just need to find one instance. That's why it's OR. But this one must be AND because both must be the same. Okay. Okay. So now we will look at cave. Let's. Actually, I want to solve this because this problem is in the middle of nowhere. Okay. Given two strings S and T. So how I'll approach this is that I will, if I can't solve it within like by maybe 6:30, I will wrap it up and go to the solution. I will use hints. I will go through the topics, hash table, string, and sliding window, and the recommended time and space complexity. So just to look at the question first, I mean, we sort of got a glance of the space complexity, right? So given two strings S and T, return the shortest substring of S such that every character in T, including duplicates, is present in the substring. If such substring does not exist, return an empty string. Okay. You may assume that the correct output is always unique. So in this case, the substring is YXAZ, right? YXAZ because it includes XYZ. So this is the shorter substring. Okay. This one. Okay. Okay. So the one thing we gotta check is if T dot length is greater than S dot length, then I have to return empty string because T is supposed to be a substring, including duplicates. Okay. So you should aim for a solution with M is the number of unique characters in S and T. Okay, so I think I'll definitely need a map. So given this, it will likely be iterate through S one pass because of ON time. And then M space complexity means that we need a hash map for S and T. Okay, so I'm gonna take some time to pause and think. Okay, I'll review one hint. Brute force solution would involve checking every substring of S against T and returning the minimum length valid substring. Right. So can you think of a better way? Maybe you should think in terms of frequency of characters. Okay. So we need to find substrings in S that should have at least the characters of T. We can use hash maps to maintain the frequencies of characters. It will be O1 for lookup. Can you think of an algorithm now? Of course not. So substrings in S, at least the characters of T. So this is already covered. We can use hash maps to maintain the frequencies of characters. It will be O1 for lookups. Okay. So we can use a dynamically sized sliding window approach. Clearly, we iterate through S while maintaining a window. Okay. If the current window contains at least the frequency of characters of T, we update the result and shrink the window until it's valid. Okay, cool. We should ensure that we maintain the result substring and only update it if we find a shorter valid substring. Additionally, we need to keep track of the results substring length so we can return an empty string if no valid substring is found. That should at least have the characters of T. Okay, so for let I go 0, I less than t dot length, plus I. We will do, let's do a hash map. Let t map is equals to new map. Let, then s, I only need a t map, I believe. Oh, I probably need an S map. Because then I will just instantiate first and see how it goes. T dot length, I will do t map dot set t map dot get sorry t I t map dot s t I. Then we will do t map dot get ti plus 1 else 1. Okay, so I think I can repeat this for s as well. S map t s map s I plus 1. Okay. So at this point, what do we do? We will iterate through S. So now I have a hash map that goes over, that has the frequencies of each character, right? So we let left equals to 0, right equals to 1. So while right is less than S dot length, I will iterate. So we'll use this as a dynamically sized window approach. So window approach, we always use this. Iterate through S while maintaining a window. If the current window contains at least the frequency of characters, we update the result and shrink the window until it is valid. Oh, so the pseudocode might be we keep moving right to look for new characters that can okay, then maybe I don't need this. Right. So we keep moving right to look for new characters that are part of T. So we iterate through S while maintaining a window. If the current window contains at least the frequency of characters from T, we update the result and shrink the window until it is valid. Okay, then when we find something, we shrink from left. We remove the elements until the part of T. Okay, then once we remove, right, we can continue going. So in this sense, for this, right, you go nope, nope. So you go nope, nope, yes. Then you move until here. So yes, nope, nope, yes. Then if you find something, you will try to remove. But then the thing is, the hash map of S only says that I have one, so I cannot remove. Then I yes. Then I nope. Then I yes. Then if I add this, I can remove. Use S map to see whether we can remove. We can remove. Keep moving right to look for new characters that are part of T. Add to S map. Okay. Then when we find something, we shrink from the left. Remove elements that are part of T. But so we we can possibly remove characters if from the left if S map has something. If S map has redundant date characters. So in this case, we'll move until here, then here, then Z. Right. So it will go from here to here. They will check that, okay, now we have a Z. Okay. Then I can remove Z and go from here, and go from here, and go from here. And then continue. Yeah. So after that, so this is very easy. So I just do S map dot set and S right. Okay. Sorry. S map dot set S 0, 1. Okay. Then P map dot S right. Question mark T freak. S map dot get S right plus 1 or 1. Okay. So we keep moving and then we add to the mass map. Then we find something. If so const current right char is equals to S right. Okay. So instead of this, I'll return as current right char. So if current right char, if T map dot has current right char, then we will shrink it. So if T map has this character, else we shrink it from the left. So we'll do left while we shrink from the left. So in this case, we reach here, right? T map has this character. So while left is less than right, I will do if T map does not have this S left, then I'll do T S map dot delete S left. Right. Then I will continue, else I break. So the moment I find something, I break it until part of T. Right. So if I need another case, because we can possibly remove elements. Okay, so what we want to do is else if. So else if we need to check, okay? If smap dot get s left. So if I get this character, if I get z, dot get s left is greater than t map dot get s left, the same character, right? Then am I missing something? Oh, oops. Should be a closing, opening. So can remove characters from the left. I can do s map dot delete s s left. I continue. So this one can probably just put this line in the middle of here. Okay. So if tmap does not have this current character, what do I do? If it doesn't have, then I'll just continue lor. No choice. Okay. So while left greater than, I'll just do left plus plus. Left plus plus. So in this case, I will do 0 set. So I do 1. Hmm. Maybe I should do 0. I don't need this line. So the window starts at both at 0. Okay. Then current character is this smap.set. So doesn't have anything, right? It will get 1. So smap will have O equals to 1. Then if tmap has O, which it doesn't, I'll just continue. So I'll just move right plus plus. Actually, I shouldn't do this. I should just do right plus plus. Yeah. So do this, doesn't, I'll go on right plus plus. So I get this U, not inside, right plus plus, Z. So tmap has this current character. So while left is less than right, so left is at 0, right is at 2. If tmap doesn't have O, right, I will delete and I'll increment. So it becomes like that. Then I'll delete and I'll increment. Then it just become like that. Okay. Then I do right plus plus again. So it's like that. So it gets O, don't have, continue. D, don't have. Y, continue, have. So if tmap doesn't have this character, I can move into else if. So is it redundant? No. Then I break out of this while loop. Then, so the first check is whether tmap has Z, which is how it does. Then we check if Z is redundant. Then we continue. Then X. So X is also correct, the same flow. Tmap has this character, while left uh less than right. I will check. It's not redundant, I will break. So then after that, I'll go on to A, right plus Z. Okay. So now Z, we will see that Z tmap has this character, but it is redundant because we have added it at the start. So it's 2. So we will delete it and then we will shift to here. And then doesn't have this character, shift it, become here. Doesn't have this character, we'll shift it, become here. Does it has this character, it's not redundant, break. Okay. Then we do right plus plus. So now, if all goes well, I will console.log map t map map console.log s map. All right, so I run. Hopefully, there's no infinite loop. So let's see. Hold up. Hmm. So it's not from A. A is part of the loop. Okay. D is not. Okay, so clearly my algorithm worked here, but I feel like it didn't work somewhere. So I will use a test case. I will use this character as S, this one as T. Then I'll run it. Oh, I can't delete. I need to reduce the count as map dot set reduce. So set as left as map dot get as left dot has. Then we'll do as map dot get as left -1. Oh wait, it should have, right? Because I already passed that check. Yeah, so this is correct. Okay, std out, I get A, B, C, N. Oh, so the algorithm is correct. Haha. Z, Y, X, A, V. So I need to create the string now. Okay, the algorithm is correct. So I need to create the string. Okay, so can't get cocky, can't get too confident. So right now it's about 6:10. Spent about 20 plus minutes on this question. Now I just need to add a string and return it. So let me add a string. I will just check. So I need to create an answer, right? Answer goes to this. Okay, let's look at the hints again. So least frequency of characters, all right? So we can use a dynamically sized level update. If the current window contains at least the frequencies of characters from T, we can update the result. So this is the update the result part. Okay. So now in the event that I iterate all the way and I get this, right? Before I go to the plus plus, can run a check. But that will be OM time. OMN time. So I should only set the string when it has validated all the checks. Hmm. Okay, let me think about this. Do, 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 do. Keep moving right to find the correct. Okay, how do I check if all the characters shrink the window until it's valid? Okay. Dun, 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 dun. Dun, 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 dun. Left plus plus. So after I finish this, I break out this loop. So T map has current characters. I can just do a very simple check. Right. Left and left is less than right. Left is less than right. Actually, I can get all the because this one I don't want it to include V, right? No, 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 no. We need maintain the result substring, only update it if we find a shorter valid substring. Okay, current chart. So I will get pop, pop, pop. So if we only want to update the string here because this is when we find something. Okay. So if T if has current if okay, if T has the current right character, right? So that means the character that I'm currently at has to be pushed in. So I will do a then maybe I'll update answer equals to answer uh dot length greater than uh s dot slice left right. Then we'll do s dot slice left to right else answer. So at the end, maybe we can. I don't get an STD out. I use splice, right? I have to use what does slice do? Ah, okay. If answer equals to empty string, then I will do answer equals to uh s dot slice left to right. Else I'll do no, I can't do this. Let's try. Oh, this seems like the correct place to do it. What if I just return? So I don't think it's correct. Ah, okay. So I think at this point we can safely say that this is an edge case because the characters technically they have the same count, the frame frequency, right? But they are not substrings. So we can only set answer as a slice when tmap contains when after sorting out characters from S will only contain T. So all this thing is to get rid of the is to resize the window. Yeah. So if it doesn't include the character, right? Not here because does not include. Okay. So it's good that we passed 25 test cases. I just need one is substring function. So maybe just create it is substring A B. So so uh S then substring. So I'll just do return S dot uh includes substring. So includes should be right. So if this dot is substring S and answer, then I'll return answer. Else I'll return empty string. I'll use this test case, run. Oh, it's ABB. Includes. Okay, this is wrong. So console.log as substring as dot includes substring. Because I'm slicing ab because of this. Oh man. Okay. Oh wait, I can just reverse it. I'll just do T. Right. So this one just checks if P includes this substring to check ordering. So this is just to sanity check to see if ordering is the same. Oh, the first case fails. Hmm. Eh? Wait. No leh. Hold up. Let me I think I'm misunderstanding the answer. Okay, let me just run. And then this case. Why is the output expected to be? Nothing. Oh, right, because we need to check the length. Oops, is valid substring. So we need to put the substring the answer we got with t. So if t return t dot length is greater than substring. Okay, so if it's greater than equal, then it can be. But if the substring is a substring of S, so if the substring of S, if substring of S is shorter than T, it cannot match T. So I'll just return if this dot is valid substring of T and answer, then I'll return answer, else I'll return this. Hold up. T's length is if it's a valid substring means that oh sorry, the other way around. So substring of S is shorter. So it's valid. Hold on. Answer is bank. So the length is longer than if it's a valid substring. Oh, T must be shorter. Shorter. Oops. Huh? Hold up. Let me console.log T substring of S and then we'll run. Okay, so substring of S is oh shit. Haha lol. Okay lah. Just cannot be shorter. Okay, let me just put it this way. Substring of like greater than is greater than equal to t dot length. Okay, then we'll run it. Should pass everything and we all right. CWAE. A CA. I got where's the AF? Oh, okay. So this is another problem. So this one is we're always looking forward to the next one. So we just have to make the decision here. So we do as answer equals to this one. Then we do answer. Then we do s dot slice left to right. Else we have to check if uh answer dot length is smaller than s dot slice left to right. Then we will do answer. Else we do slice s dot slice left to right. I hope it runs. Yeah, I'm pretty sure this test case will pass now. No, it doesn't pass. Eh, okay, so we do one, one, plus one. Okay, wait, maybe we'll just log and see whether we will capture. So C A can we? Okay, then we get another C, then we get this. We do get CWAE. Okay, so we do. Oh my God. Oops. Compare the uh we do right plus one minus left should be like this. Okay, I'm just gonna I give up. I don't know how to compare the length. Okay, F is zero need. Okay, you know what? I'm gonna use ChatGPT. Okay, check with ChatGPT. So turns out we need to look at things from a take a step back. All right. So the whole idea of keeping a T map and an S map makes sense, right? So and we will still iterate right from zero all the way to the end, and then we will keep incrementing. We will just try to hash it once, right? So we will increment all the way to the right. Uh-huh. And then when we find something that the current character, the T map from S that Tmap also has. And if that at that point Tmap's count and Smap's count is the same, we will increment half. So it means we fulfilled one letter. So when we reach the point, we keep iterating because this while loop actually is only when all letters are fulfilled. All letters fulfilled. Then we shrink. Then we shrink. Okay, so we'll slice left to right plus 1 to include right. If answer equals to empty string, means there's nothing. And then now we have half equals to need. Then candidate length equals less than answer length. Answer is equals to candidate. All right. So we will keep removing. If tmap, so tmap has left character and smap get left character is less than tmap's requirement, then we'll do minus f minus minus. After shrinking, we lost the character, needed character. Okay, breakout of while loop. While loop with the next. So if smap dot left char for cleanliness. Okay, so if these two, we will start shrinking. Okay, so we'll keep shrinking until we have the smallest possible candidate. So at this point, we can just hit console logging answer, right? Then we will run and we'll see the test case for this. So the first round we will get. We'll go here, we'll add, 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 go here, we'll add. Then have is equivalent to need. So this is a O1 check if hash maps are involved. Since ordering not important. Okay, so now it checks. Then we will reduce and we'll get this, right? Then we'll break out the loop. So right now we're here. So we will go in, add, 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 add the next C, right? So at this point, the candidate is too long, right? So we can always console.log candidate. And candidate dot length is shorter than answer dot length, right? So we will run and we will see that actually we have more candidates. So we have web. This is okay. Then we will do this until C. Okay, maybe this one we'll put also. Yeah. So we'll run. So correct. We will get this all the way until here. And then it's false. Right. So we don't set it. And then we'll shrink the window from the left. And then now we don't have an A, we will continue. So we will continue until we get this, which is the next one. False. We shrink. False. We shrink. Until we shrink until we get to here. Okay. So after that we minus, then it doesn't fulfill, then we continue checking. And then we get CWA is the shortest, and then we continue. And then eventually this will become a candidate. So for this, I'll admit I got bested. So yeah, the time complexity will be ON to go through this loop and OM for this loop and the space complexity will just be keeping Tmap and Smap. Whew. Okay, so let me submit. Oh, what? Hold on. Eh? Did I remove something? Oh yeah, I removed something by accident. Just need to remove this. Run. Yep, I'll just skip all the console logs. And yeah, okay. Good run today. Time for dinner. Time now is 6:50. Slightly under 1 hour.